All right, let's use technology to explore functions. All right, let's start with a linear function. This is y equals 2000x plus 5000. And we're going to use a table of values to view the graph in an appropriate window. An appropriate window means we can see key features of the graph. And then for example, the x and y intercepts, where it crosses the x and y axis, and where we can determine what the domain and range of this graph is. Okay, so I have already entered this graph in Desmos.com, which I will be sharing with you right now. Whoops, let's go with this. Okay, so they have graphed, Desmos.com has graphed this, and all I can see is, well, it looks like there's a x-intercept, but I do not have a clue. It looks like it goes straight up and down to me. This is not a good viewing window. So one trick to do in Desmos, there's this little gear up here. If you touch that and then you touch this table, it gives you a table of appropriate values. Now I can see that, well, no wonder I'm clear up at 1,000, 3,000, 5,000, 7,000. So go over to the right up here where the wrench is, and that gives me a viewing window. And I'm going to change my y-axis. I can't keep it at 8. It's got to be, I'm going to go all the way to 10,000 because I see 9,000 over here in my table. Okay, so let's take a peek at this origin. Okay, so now there's that x-intercept that I was talking about, sure enough, but now I can see the y-intercept. Now the cool thing about Desmos, it will key in on specific points for you, okay? So I've got my intercepts right there, and while I'm here, let's think about the domain and the range. So the domain are all the x values of this function, which looks like it goes forever in both directions, as any linear function does. And the range also goes up in both directions, unless it's a horizontal line. Okay, so we've got our info. Let's go back to the other screen, and I will record. Not yet. Let's try it. I will record the answers that we talked about. Okay, so we did that. So the x-intercept, I believe, was, oops, let's go to black, was 0. Sorry, the y-intercept was the 0, 5,000. And the x-intercept was negative 2.50. The domain and range we decided was forever in both directions. So the domain would be, I'm going to do the double R, that means all real numbers, which is from negative infinity to infinity. And the range would also be all real numbers or negative infinity to positive infinity. Okay, all right, let's take a look at a quadratic function. Now we know a quadratic function graphs to be a parabola. And if we remember, if the a term, which is in front of x squared, is negative, it's going to be an upside down parabola, which has a vertex maximum point at, well, no, that's not the vertex. And this is our y-intercept. If you recall, these are our key features. So when x is 0, y is 40, and we know it opens down. So we do need to get a few more things from this. So let's use the table to view it in an appropriate window. Then we can find the x-intercepts, the y-intercept, and now there can be more than one x-intercept of a function if it's a parabola. And then also they want the maximum value and where it occurs. Okay, so let's first of all go into Desmos again. And I have already entered this. So I'm going to get rid of the linear graph and put in this. Now the scale, I should go back to, well, this scale is already a bit large. Can you see that? How on the y-axis, the scale is pretty large. And it almost looks like that's my vertex right there. But I'll tell you what, this is the thing about technology. You really don't know. I'm going to go ahead and get a table of values. Now, see, it almost looks like that's my vertex and my y-intercept. And I'm going to zoom in on this. So if you take your fingers and you pinch the screen out, you can see that, oh my goodness. All right. Now the cool thing about Desmos is all you have to do is click in the area and it will give you key points. For example, oh boy, so it gave me 2 points there. I'm going to open that up so you can see that one of them is the vertex, one of them is the y-intercept, and then I have my 2 x-intercept. Those are the important points of any parabola. All right, so we see the numbers here, negative 0.2562. That's my x-intercept, and the other x-intercept is positive 0.1562. And the y-intercept is 0.40, and the vertex is at negative 0.05, 42.5. All right, so I'm going to write those down in my answers here. Okay, so the x-intercepts were, I'm going to round that to negative 0.260 and positive 0.160. You can check that if you're using Desmos as well. The y-intercept was, as we knew, 0.40. We knew that from our equation up here. And then the maximum was at negative 0.05, 42.5. Now see how messy all these numbers are? That's really when technology is helpful, when we have a bunch of decimals. Okay, so the maximum function value is actually the 42.5 because that's how high it went. And where it occurs is actually at negative 0.05, the x-coordinate. Okay. All right, let's move on to solving equations, and let's bring in some inequalities. Now, inequalities is where it's less than or greater than. So first of all, let's take a peek at this graph. F of x is a parabola, and g of x is a line. You can tell by the x squared, and you can tell by this just has an x. And we're going to find out where these equations are equal. Okay, so if we were going to do this with algebra, we would set negative 10x squared minus 5x plus 3 equal to negative 3x minus 9. And then we would solve this equation for x. Well, we'd have to set it equal to 0 and either factor it or use the quadratic formula. Well, we're not going to do that because we're using technology, and that's what's cool about technology is all you have to do is, and I've done this already, is put the graphs in Desmos. Oops, sorry about that. Put the graphs in Desmos right here and find out the x-coordinates of where they intersect right here and right here. And so those x-coordinates are negative 1.2. I'm going to put this on a line. This is my x-axis. So at negative 1.2 and positive 1 are where the parabola and the line are the same, why they are equal. Okay, they both are at negative 5.4 at negative 1.2, and they're both at negative 12 and when it's 1. Okay, so that's where they're equal. So we would say, oh, well, x equals negative 1.5, x equals 1. All right, we got those. We got that solution right here. Now, though, they want to know where is the function f less than g and where is the function greater than or equal to. Now, remember, f is our parabola. So I'm going to write that. Where is the parabola below means less than the line. That's what this means. Where is this below this? And you can see that the parabola, I think I'll use a thin pink, really thin, right here and right here, the parabola is below. Well, we have to say the x-coordinates where it's below. So I'm going to refer to this x-axis on the bottom, and that's going to be for all of these x values, which are right over here. That's where my parabola is low. And for all of these x values, which will be from here that's where my parabola is low below. Okay? And so to answer this question, where is the function f less than the function g? It's not equal to, okay? Then we would say, well, that's going to be from negative infinity to negative 1.2 union 1 to infinity. And these values, I'm going to go back to the yellow. These values match the pink values in the line. And while we're on the subject, let's just take a peek. I'm going to do it in a different color. Let's do this light blue, small. Where is the parabola greater than or equal to? And that's going to be, let's go back to the graph, right here. This is where the parabola is above the line. And that's going to be right here on the x-axis, in between the 2 points where they intersect. And so I'm going to answer that with, well, it's greater than or equal to. So this one we want closed brackets for the equal to. And that's going to be between 1.2 and 1 using interval notation right here. Okay. All right. Let's do another one of those. All right, so here's another graphing utility to solve. This is my equation. Oh, I didn't get it big again. All right, let's go big. All right. Okay, so here I have, where's my parabola right here? Negative x squared plus 4x plus minus 76. Where is that greater than negative 12? So I have graphed this in Desmos. And you can see that the parabola is in red and it opens upside down. And negative 12 is just a constant line. That's just a straight line at negative 12. So here we have y equals negative 12. That's the blue line. And then the parabola is the red line, the red. Okay, so the question is, where is the parabola greater than, I want to write that. So this, where is the parabola above, that's what greater than means. Spell it right. Above the line. Okay, so we take our two numbers here. These are the keys. There's a negative 1, just the x coordinates. We just want the x coordinates. So we want the negative 1 and the 5. That's where they're equal. We want to know where it's, in this case, above, because it says greater than right here. Okay, and let's get little. Okay, so right here is greater than, so that's this. The parabola is above negative 12 right there. So that would be in between the negative 1 and the 5. And if you look at the x-axis, right here is negative 1 and right here is 5. These are the x coordinates where the parabola is above. So we write that as, since it's greater than, we keep it open, it's not greater than or equal to, it would be negative 1 to 5, and that is the interval where that equation is greater than negative 12. Okay, let's take a break now and continue in another video.